So now I'm going to introduce our first speaker, Andrew Ng, who does not need introduction at all. If any of you does not know Andrew, probably you are not in the AI world. I have known Andrew for more than 10 years. When I was at Bosch Research, we collaborated with Andrew when he was a professor at Stanford. And at that time, his group was working on deep learning, which I feel kind of too fancy, doesn't have any practical applications. And later, when I was at eBay, I invited Andrew to give a talk at eBay. He actually gave a talk on how deep learning can be applied to both image, speech, and natural language processing. And that was back in 2010. And for me, that sounds very just far-fetched. Little did I know that after 2 years, Andrew and his student started a Google Brain project. And since then, deep learning has become a big part of our today's AI technology. And Andrew is passionate about education. He joined Coursera. He founded Coursera, that became the largest education site. He later joined Baidu as a chief scientist and helped Baidu to develop their technology. I think now Andrew is back to his passion again, starting the deep learning.ai. So let's hear from Andrew and help me welcome him.
Thank you. Let's see, is this turned on? Do you hear me okay? All right, awesome. Thanks a lot, Julie. Known Julie for many years. I was very happy to get to speak with all of you this morning. So as preparing for this presentation today, I spent some time trying to figure out what might be most interesting or most useful to you. And what I thought I'd do is share some thoughts on, well, there's a little bit of echo. I wonder if you can turn this, let's see if this works better. All right, what I thought I'd do is share some thoughts on the recent rise of AI and deep learning, and then also give some advice to all of you that want to break into AI or help your existing company use AI or develop your own career in this sort of pretty exciting AI field. And I'm going to say some things I've said at other conferences before, but also some of the things I say here will be things I don't think I've presented in other audiences before. Great. So some of you may have heard me say before that AI is the new electricity, right? And what I mean by that is that starting about 100 years ago, the rise of electrification in the United States transformed every industry. Everything from agriculture, which was transformed through refrigeration, to transportation, to communications, transformed by the telegraph, to manufacturing. Every major industry was transformed through the rise of electricity. And I think the rise of AI, or really maybe especially deep learning, but other pieces of AI as well, has advanced to the point where we now see a surprisingly clear path to also transform every major industry. And I think that, and this creates a lot of excitement as well as a lot of opportunities for all of us, for all of you. But there's a lot of echo. I guess, can people hear me okay? No? All right. I wonder, when is this way to, any ideas? Say that again? All right. Is this better? Test, test. Is there a handheld mic that will work better? Maybe this room just has echo. Test, test.
I'm going to put this here just in case.
How is this? And, all right. What do you want me to do? Oh, okay. All right, so if I speak like this sounds okay? All right, awesome. Hey, someone please let me know if I become unintelligible, because I sound great to myself, right? So as just a recap real quick. I was saying that AI is the new electricity. About 100 years ago, electricity transformed every major industry. And I think today, AI has advanced to the point where we see a surprisingly clear path for it to also transform every major industry. And there's a lot now, and there's so much excitement about AI. Despite that, many of you probably know that almost all the economic value created through AI today is through supervised learning, right? And supervised learning just means learning X to Y or input to output mappings. And I think there were maybe two major waves of progress. One was we took traditional supervised learning, machine learning problems, and with the rise of deep learning, it just started to be much more accurate. So image recognition, input a picture, output, what object is this, such as an index from 1 to 1,000, right? Like an ImageNet challenge, say. Or the most lucrative application of this in the world today might be online advertising, where we input an ad, input some information about you, and predict will you click on this ad or not, 0 or 1, right? Because for the large online web advertising platforms, every click is money, and so there's a very large incentive to show you the ad that you have a 5% rather than a 3% chance to click on, right? So it's extremely lucrative. And I think this was maybe the first wave of progress, and it enabled a lot of new products. And then another second wave of progress I thought was exciting, and is still continuing, is when the output Y is no longer just a number or just an integer, but is, for example, speech recognition, where you input an audio clip and you output a text transcript. And where now the outputs of our deep learning algorithms are no longer just a number, but a much more complex data structure, such as a sentence, or input an English sentence and output a French sentence, that's machine translation, or TTS, actually, input text and output audio, that's text-to-speech. And the ability of deep learning algorithms to output not just a number, like traditional classification and regression problems, but to output much richer data structures has enabled another wave of, I think, applications. And maybe take and maybe just one example that's sort of in between these would be if you input, let's see, an image and maybe the radar readings, right, and output position of other cars, right? And this has become one of the key components in building self-driving cars. Like actually, I'm on the board of Drive.ai, right? And it's really not just outputting a single number, like is there a car or not, but for example, outputting bounding boxes for where other vehicles might be. Or the rise of chatbots, where you input a phrase, like a user utterance. Like a user might say, oh, I'm feeling really down today. And well, what does that I'm feeling really down today mean? It means that I guess you're what, depressed or unhappy, right? And output what is the mood of the user. But so I think the rise of these things is allowing the rise of new applications as well, like Wobot, which I'll say a little bit more about. One thing I want to try today is I think that a lot of these concepts of the rise of AI are best illustrated with examples. And so since I've been spending a lot of time with Wobot and with Drive AI as a board member, not as an employee, I'm going to use both of them as illustrative examples to try to convey to you how AI is changing a variety of industries. Now, it turns out that a lot of these ideas have been around for a long time, but these ideas have started working really well just over the last, 3 years or something. And I think Junli made an interesting comment just now that 10 years ago or whenever, there weren't a lot of good opportunities in AI, and a lot of people feel like, wow, this AI machine learning thing came out of nowhere. But as an AI deep learning insider, we actually have AI insiders actually have a very different perspective, which is I feel this stuff has been working, let's say 50% better every year for the last 20 years. And as an insider, if I see this, let's say 50% year-on-year growth, is just, nothing's changed. It's just continues to get better by 50% every year. But to people watching this from the outside, 50% year-on-year growth or exponential growth often looks like it came out of nowhere. So as an AI insider, I actually didn't feel the phase transition as much as people that joined the field more recently. But so if a lot of these ideas about neural nets and deep learning have been around for a long time, why are these ideas just now taking off? Well, there's this picture that I tend to draw, but I think the number one reason for why these algorithms are working so much better is scale, meaning scale of data as well as scale of computation. So if the x-axis is the amount of data and the y-axis is the performance, then if you look at traditional machine learning algorithms, such as logistic regression or support vector machine, maybe decision trees. Excuse me, wow. For a lot of industries, with the rise of the internet, with the rise of mobile, with the rise of digitalization of society, for a lot of industries, the amount of data we have marched to the right over the last 20 years. But it was as if the traditional generations of learning algorithms didn't know what to do with all the data we had. So you might have seen companies build really, really large logistic regression models using, I've seen models with north of 1 billion features, right? It gets a little bit crazy, where you take very high order polynomials of your raw input features just to drive more and more features in the system for making online ad click-through rate prediction or whatever. But somehow we just weren't able to scale the traditional machine learning algorithms that well, and polynomial features was not cutting it. And support vector machines did not scale well to large training sets, at least if you use the nonlinear kernel. So this just didn't work. And I think with the rise of deep learning, what we saw was that if you train a small neural network, performance maybe looks like that. If you train a medium-sized neural net, performance maybe looks like that. And if you train a very large neural net, the performance maybe just keeps on going up. And so for a lot of problems we're seeing, take speech recognition, right? If you have enough data, and for speech recognition, maybe this would be 50,000 hours of speech data. If you have enough data, an end-to-end deep learning algorithm, can now really, frankly, surpass human-level performance in the ability to transcribe speech, at least in limited contexts. But to process, say that again? Oh, why is it bad again? What? Oh, my voice is becoming muffled. Can the audio people? Okay, maybe, all right, is this okay? I will try to speak clearly, consistently, but if, please raise your hand or yell at me again if I become muffled, and I'll repeat. Yeah, all right, thank you. Where was I? It's ironic that we'd be speaking about speech recognition when I am muffled. All right, so to process, say 50,000, or now some teams use north of 100,000 hours of speech data, you really need, very large neural networks. And so some of the most crazy, bleeding edge AI teams now actually have, I'm seeing this type of org structure become more common, where an AI team has a sort of machine learning, deep learning set of engineers, as well as a set of systems, or sometimes HPC, high performance computing engineers, to build the very large machines to support the AI teams. One fortunate thing, though, is that thanks to really the rise of, frankly, at this point, still mostly NVIDIA, although I think Intel and AMD are working hard and actually I'm seeing traction there as well. Scalable GPU computing is becoming more and more widespread, and so fewer and fewer teams need to do the crazy things that I've done, in some of the teams that I used to lead to really push the bleeding edge of HPC. I think in addition to scale of data, so to get the best possible performance, you sort of need a lot of data, and you need to train a pretty large neural network. And I think one of the reasons that's underappreciated for the recent rise of deep learning is the algorithmic innovation. But it turns out some of the algorithmic innovation, in my opinion, mostly drove scalability. Not all, but just some of it. I'll give you a concrete example. It turns out one of the huge breakthroughs was instead of using a sigmoid activation function, use a rectified linear unit activation function, right? Sorry, I'm getting pretty deep in the technical details, but in a neural network, you have these things called activation functions, which transform your input in nonlinear ways. And I think this was a surprisingly big leap forward in deep learning, not because this function, called the rectified linear unit, is a fundamentally better representation for images than the sigmoid function. Instead, I think it's just that the sigmoid function has derivatives that go to 0 on the left and right, and so it's just very difficult to train a neural network. With a bunch of sigmoids, your derivatives go to 0. Whereas for this function, called the ReLU, its derivative goes to 0 only in half of the plane, I guess, and so this is just much easier to train. So I feel like a lot of the even algorithmic innovations like this and Dash norm and so on have just made neural networks much faster to train, and I think that's also accounted for a lot of the progress. But beyond that, I think there has been real algorithmic innovation as well. When we look at some of the neural network architectures, some of those architectures are actually really clever. I'll say a little bit more about that. Now, in terms of the value created through these different learning algorithms, I think that still supervised learning, creates the most value by far in terms of, frankly, economic value, social value, better user experience. And I think I would rate transfer learning second to that, followed by unsupervised learning, followed by reinforcement learning. So I don't know, one question I get asked a lot is, like from PhD students, right, is where should I do my PhD? And I think that at least today, there's actually, in my opinion, there's actually a fairly rapid fall off in terms of the value created by these types of, by these categories, by these buckets of technology. So talk about supervised learning. Transfer learning is when you learn from one task and apply it to a different one. And I think really in computer vision, it's very difficult to do computer vision these days without using some form of transfer learning because the data sets aren't big enough. Unsupervised learning is very valuable in one niche example, which is learning word embeddings. And that turns out is in production in many companies, but there's also a lot of open-ended research that still needs to be done. And reinforcement learning has had an amount of PR that is vastly disproportionate, I think, to the actual economic value created. It turns out that supervised learning has a huge hunger for data, and reinforcement learning is even more hungry for data than is supervised learning, right? In reinforcement learning, you get a very weak reward signal that tells you when you're doing well and when you're doing poorly. And so you kind of need even more data as a rule of thumb to get a reinforcement learning algorithm to work than the supervised learning. So I think reinforcement learning has been great at playing games because if you're playing a video game, you have self-play. You could play millions of games or infinite numbers of games against yourself and the computer. And it's also getting traction in some robotics applications because if you can build a simulator for a robot, basically build a video game for the robot, then your robot can get infinite experience in the simulator. But outside of games and robotic applications, it's kind of model-based reinforcement learning, where you can build a simulator. I think this is still, I don't see this in production nearly as much, frankly. Having said that, one of the wonderful things about this field we work in is, I drop a chart like this, and 2 years later, the ordering has completely switched around. So this is just a picture today, and with machine learning breakthroughs or whatever, it's entirely possible that this ordering will be dramatically different in a few years, right? And then one other interesting thing you see is I feel like, structured data or relational data versus unstructured data. A lot of the PR and the excitement and so on about the rise of machine learning has been on tasks like speech recognition and computer vision, and that's unstructured data, right? So images, audio, text is unstructured data. Structured data refers to like relational data, like your company's database of what customer clicked on what web page and who bought what and at what time did they send an email to your customer service, your relational database data. And I think that even though there's much more excitement in the public about machine learning on unstructured data, more value is created through machine learning on structured data still than unstructured data. It's just that structured data tends to be very verticalized, right? So if you're a large web search engine, you have a very unique structured data set. If you're a healthcare system, you have your own unique structured data set. So there's just less excitement about work on structured data. Whereas images, well, everyone likes to look at images and everyone listens to audio. So the machine learning progress on unstructured data is much more accessible, but I see more value created on machine learning on structured data still. But a lot of the new and upcoming exciting opportunities are actually on unstructured data. Things like Drive.ai, Robot, these are new categories of applications. So Amazon Alexa, these are new categories of applications that are enabled by deep learning on unstructured data. So I would say both of these are actually very valuable. This fall off isn't as sharp as a fall off on the left. Now, of course, focusing on maybe especially supervised learning, the Achilles heel, the weakness is the need for labeled data, right? The need for a very large labeled training set. And I think that this is creating changes in corporate strategy as well. So for example, there's a very common pattern you see play out when you're building new AI products, right? Which is that somehow through blood or sweat, sorry, maybe not blood, just sweat, through sweat and hard work, you might scrape together a data set. Let's say you're a robot, right? We just sit together, write down things a user might utter, and use machine learning to say, all right, if you say I'm feeling down, that means you're depressed. Turns out, another surprising thing is a lot of robot users report that they're hungover, and so this is a true thing. Users will talk to, so robots is a therapist chatbot. Mental health actually is a bigger spend in the United States than heart disease. Heart disease in the US cost was $147 billion. Mental health is a $200 billion problem. Oh, okay. Thank you. All right. Let me see. Is this any better? Still muffled? Okay. You want to speak at a higher pitch? Does that work better? I see. Okay, I will speak more slowly. Do I need to speak at a higher pitch as well? This sounds very strange. That was his suggestion. All right, I'm not going to do that. I can't. So one of the ways that the need for data is changing corporate strategy is that today, fortunately, the AI community is very open. And so most ideas get open source at some points, right? And so a lot of, it's actually not, maybe to take a concrete example, I have a very good sense of web search technology, right? Having worked at a couple of the two of the largest web search companies in the world, so I actually have a very good sense of how web search technology works. But despite knowing, very well how web search works, I today do not have access to a data asset that tells me if you search for United, you are more likely to want United Airlines in the USA, but if you search for United in the UK, you probably want Manchester United, right, the football team or something. And so that data asset, that if you search for this term, you're more likely to click on this than that, is a very valuable data asset that enables the leading web search companies, all of them really, Google, Bing, Yandex, Baidu, allows the many leading web search companies to show you the most relevant results. So I think one pattern we're seeing is that the data asset of what URLs you're likely to click on is the defensible barrier to the web search business. And so today, I honestly have no idea how a small team, I don't know how to create a small team to build a competitive web search engine with knowledge of the algorithms, but not knowledge of, but not the data, but not the labeled data. And this makes the web search business extremely defensible. And so those of you building new businesses as well, when I build a new business, one of the criteria I use is can we plan out a sequence of steps to acquire sufficient data to make the new business defensible. So one very common pattern is somehow through sweat acquire enough data, and that allows you to launch a product that is not bad, that's kind of adequate. And having a good enough product allows you to acquire users, and having users causes your system to get more data, and after some period of time, this then becomes a defensible business. And maybe one concrete example, if you take Wobot, right? This is a digital mental health care chatbot. So what heart disease costs the US about, was it $150 billion or so? Mental health care spending in the US is over $200 billion. So when people talk about AI in healthcare, people often think about heart disease and cancer and so on, but I think mental health is actually, at least by spending in the US, is arguably an even bigger problem, and it causes a large amount of mental anguish. But what a company like Wobot can do, or actually has done, is through sweat, just manually labeled a lot of data where we learn a mapping from utterance to mood. So a user might say, so drunk last night, have a huge headache, and that means the mood is hungover, right? So Wobot recognizes, I think, about 68 moods in a small piece of it, right? It's an NLP component. But through sweat, you can get enough data to launch a product that's pretty good, and users seem to like it, although I still see a lot of room for improvement for the product. And but having a product, allows us to have users, and this gives the system more data, and this creates a positive feedback loop that over time results in a very large data asset that makes the business very defensible. So as far as I know, Wobot today has by far the largest data set in the world, I think, with this type of chatbot, mental health chatbot that helps you feel better. And so I think this is still in the early phases, but allows that company, that business, to be off to a great start. Now, in addition to deep learning, there is more to AI than machine learning and deep learning. But the reason that there's so much excitement about deep learning is, I think, the following, which is that let's see, let me write deep learning, I guess. Right. There are other types of AI technologies, such as graphical models, what else? Knowledge representation, planning, right, and so on. And when I go to these conferences of these other disciplines, what I feel like is that over time, x-axis is time, our ability to build graphical models has been, slowly getting better. Our ability to build better knowledge representation systems is slowly getting better over time. And by the way, knowledge representation, knowledge graphs are actually very useful. It's one of those topics. Knowledge graphs is widely used in many companies, but the work in academia feels disproportionately less relative to the amount that's actually used. Planning algorithms are slowly getting better, and I do use all of these things in various products I might build, but it's deep learning that is taking off like that, and so this creates the richest set of untapped opportunities. And when you're working on products as well, just because there's so many things we could now do with deep learning that we couldn't do 2 or 3 years ago, that there are a lot of untapped opportunities. And maybe one way I tend to think of deep learning is, you know, if this is the things we could automate, right? Maybe 5 years ago, as computer scientists, there was a set of things that we knew how to automate. And what's happened in the last 2 years is the set of things we can automate is now suddenly much bigger. And so there are a lot of new opportunities here to build new products and businesses and so on. For example, I think autonomous driving, right, is in that set. That, you know, I remember 10 years ago going to the DARPA Urban Challenge, right, with the Stanford team. My students at Stanford were working on autonomous driving for a long time. I was hanging out with Sebastian Thrun and learning from him. But frankly, the world wasn't ready for autonomous driving because the technology wasn't there. But in my opinion, it was only a few years ago that deep learning advanced to the point where we can finally get the accuracy of the deep learning components high enough to actually build these things and make these things safe. So when I joined Baidu, I took a lot of my experience building the Stanford, one of the Stanford teams into Baidu, and then later my students and I guess coincidentally my wife started Drive.ai, right, which continued to do very well. How's my audio? Is this understandable? So? If the audio people have any suggestions, let me know. Not so good? Any suggestions? All right, let me try the other microphone. Sorry about this, guys. Could you turn this one on? Test, test. Can you turn on, could you turn on this mic? Let me try this one. Should I try this? Oh, okay, thank you. Yeah, all right, turn this one on, please. Okay. Does this work any better? Does this work? Does this work any better? All right, cool, thank you. Thanks for your patience with this. Okay, let's see, where was I? You know, all right, let me, there's a lot of stuff I could share with you. Let me just think what's most useful. You know what? Let me just, since I have just 10 minutes, let me share with you maybe the things that I think might be most useful to you as career advisor, how to go about planning new businesses you might build. Oh. Okay, we'll go back to the original one and see if this is intelligible. And I will just speak slowly. Part of me wonders if I sing this or something, will that be better? You know what? Let me just mention maybe 2 implications for your work and for that. Let me just mention some ways to spot new opportunities, right? Just what's the stuff you can do that's really exciting? Junling alluded to this earlier as well, but I think that starting around 2010 or so, we started to see speech recognition flip, in that really thanks to the work of Deng Li at Microsoft, I think he was working with Jeff Hinton as well. Deng Li and Jeff Hinton, speech recognition started to flip and become really effective. And this enabled new categories of product, such as Amazon Alexa, Apple Siri. At Baidu, I led the team that did the Baidu Duer OS and so on, and voice search. Right now, you almost take it for granted. And then I think computer vision was the next field to flip, really starting with AlexNet around 2012 and then gaining more momentum after that. We saw computer vision flip from being, frankly, not working that well to suddenly working really well. And this has created new categories of opportunities. For example, really, autonomous driving, right, uses these types of techniques heavily. And one of the lessons I've learned is that it's important to time technology. So 10 years ago was a great time for Steve Jobs to launch the iPhone, but another 15 years before that, there was the Apple Newton, which failed, right? And why is that? I think it's partially because 10 years ago, the ecosystem of supporting technologies such as screen technology, battery technology, wireless technology, it was finally ready to support the iPhone about 10 years ago, but it wasn't ready to support it 15 years ago. So frankly, I think 10 years ago was not a good time, or at least the ecosystem was not ready to support autonomous driving. But I think maybe 2013, 2014, it became ready, and hence, companies like Drive AI, and I was leading the Baidu autonomous driving team for a while as well, and so on, right? So what's next? In my opinion, NLP, I see flipping as well. If you go to an NLP conference, you will see that a large fraction of papers at the leading NLP conferences now have embraced deep learning. And I guess I'm averaging over research communities with thousands of researchers, so I'm probably going to offend someone. So this is just my personal opinion, and we'll obviously be making overly broad generalizations. But when I look at NLP, I feel like NLP is flipping, and that my prediction is over the next few years, we will see a flourishing of new applications, just as we have seen for speech, just as we have seen for computer vision, and which I think we will see more and more for NLP. And I think one of the reasons, we're working on chatbots, on robots, is because I think the right timing for that technology is around now. That I think that chatbots will be a killer app, and is finally ready to support this set of technologies. And I feel like there's another one that I think is very interesting, which is robotics. Feels a little bit behind NLP. I hope I'm not offending thousands of roboticists, but I see those debates in robotics today that feel a lot like the debates computer vision had a few years ago and speech had even earlier. So I think these are really disciplines with huge sets of opportunities. And then let me just close with one last thing, which is with the rise of the internet, one of the lessons I learned was that if you take a traditional shopping mall, right? My wife really likes Stanford Shopping Center, it's like whatever. And you build a website for that shopping mall, and maybe they even sell things on the internet. This does not turn your shopping mall into an internet company, right? So what defines an internet company? It is not just whether or not you run a website and sell things on a website. What defines an internet company? What makes Amazon Amazon, rather than some of these retailers that are being put out of business by Amazon, is not whether or not you sell things on a website. Instead, it is whether or not you have built your company to do the things the internet allows you to do very powerfully. So internet companies do much more A/B testing. We have very short cycle times. We ship a product, every day rather than every 6 months because we can, and you learn much faster that way. We tend to push decision-making power down from the CEO to the engineers and the product managers, right? Because only the engineers and the product managers understand the technology and the users well enough to make key decisions. So these are some of the things that define what makes an internet company, not whether or not you have a website. So that was the rise of the internet era. And I've been very influenced by Jeff Bezos' thinking on this, actually. How about the rise of the AI era? I think that a traditional tech company plus a neural network, or plus a whole bunch of neural networks, this does not make you an AI company. And just as with the rise of the internet, it created opportunities for new startups, such as Google and Amazon and Facebook, as well as for incumbents. I think Microsoft and Apple did a great job, right, transforming into internet things. The rise of AI gives some incumbents a chance to march forward, and also a chance for new categories of startups. Now, what is it that makes an AI company? I don't think we know. 20 years ago, we didn't know A/B testing would be such an important thing. And I don't think anyone, Google and Baidu and Drive and Wobot are very good, but I don't think any of us have the full solution yet. But these companies that are at the forefront of this tend to be very good at strategic data acquisition, just very sophisticated in terms of how we think about really the multi-year chess games we are playing to get the data asset. We tend to have unified data warehouses. If you have 50 databases siloed under the control of 50 different vice presidents, there's just no way an engineer could get approval from 50 vice presidents to get the data and put it together to connect the dots and train an algorithm. So at large companies, this is sometimes a multi-year exercise to just put things into centralized data warehouse. I think that we have new job descriptions. For example, our product managers, maybe I'll give you just one example. I feel like we're inventing new processes all the time. So again, using Wobot and Drive AI as examples, traditionally a product manager, right, might draw a wireframe to develop an app. So product manager might say, put the logo there, put a news feed there, it is Facebook, I guess, and put 5 buttons there. And the product manager might draw a wireframe and tell an engineer to implement this. And this is an example of the workflow we had developed for the internet era. But in the AI era, if you take a chatbot, right, say Wobot, if the product manager draws this picture and says, hi, I'm sad, and then whatever, this is totally useless to the NLP engineer, because the NLP engineer needs to know not what the shape of the speech bubbles is, but what are the substantive, back and forth that the chatbot needs to have with the user. Or for autonomous driving, right? If your product manager draws you this picture, and says, hey, engineer, please build that. The engineer will say, this is totally useless. So instead of a wireframe, we are training our product managers to specify the PRD, the product requirements documents, in the form of a data set as well as an evaluation metric and a request for a certain level of accuracy. And I think just as the rise of IT caused companies to develop new jobs and roles and processes, the rise of AI is having this impact on our industry as well. I'll close off with just one last thing that really surprised me. So, you know, at deeplearning.ai, we've been creating new courses on deep learning hosted on Coursera. There was one thing that really surprised me putting together some of these courses on deeplearning.ai, which was how easy it is to get into AI, right? So earlier this week, we posted a course on convolutional neural networks, and I remember being surprised that in just 4 weeks, you can learn pretty much state-of-the-art computer vision, image recognition, convness, learn about face recognition, learn about neural style transfer, learn about object detection, and I think that with the rise of deep learning, the algorithms we have are actually getting simpler because we rely more on data. And so I think that if you are not yet, and the other thing that really surprised me was after just a few weeks, you can become qualified to read recent research papers and you know, understand kind of many of the bleeding edge ideas in the field. So I think that in terms of career advice, it is easier than ever for you to learn the fundamentals, the new fundamentals of AI and machine learning and deep learning. And then beyond that, after you've learned the fundamentals, there are, you know, plenty of job opportunities, maybe in your current company or maybe in the exciting startups like some of these to keep advancing your career. So maybe if, I don't know, I have a relative that's been thinking for a couple of years whether or not to jump into AI, and I'm just telling them this is actually a time to do it, and it's easier than ever before. All right, I think I leave some time for questions, so let me just pause now and say thank you very much.
Hello. This is my phone. Okay. So I have about 10 minutes, and if you have any questions, send it to our hashtag AI_frontiers. We'll try to collect questions. Before that, let me ask Andrew a question. This is from actually one of the audience. How can we become a great AI researcher like you?
Oh, sure. No, thank you. You know, don't be like me. I'm not that great, but I'll tell you how you can be better than me, maybe. I think in terms of career progress, this is what I really recommend. First is foundations and fundamentals, and I think online content such as MOOCs, but books, blogs, you know, the deeplearning.ai courses on Coursera, those are a very efficient way for you to learn the foundations. Second is projects. One thing that a lot of people underestimate is the utility of replicating published results. So, you know, when I look at some of the published papers, when you interview for a job, people often ask you about what projects in AI you have done. If you have an idea for a project, great, do that. But if you don't have an idea for a project, one of the best ways I've found for training up, say, PhD students at Stanford is asking them to replicate other people's published papers. And if you replicate a few of those, you will magically get ideas for your own new project. So many people underestimate the value of replicating published results and try too hard to invent your own new thing rather than replicate someone else's results. So I found this to be very efficient. And then third is really, right, jobs. Because I led some of the AI teams at Google and Baidu, I am biased. If you can get a job at Google Brain or the Baidu AI group, just accept the job offer, they're great. If you can get a job at Wobot or Drive AI, accept the job offer, they're great. But even beyond these maybe most elite AI teams, there are lots of AI organizations. I think Microsoft, Facebook, Amazon are all fantastic, eBay, you know, many good AI teams. And so this is a common path that a lot of people will follow to have a fantastic career in AI.
So the next question, what is it like to work in industry versus in academia at Stanford?
Yeah, You know, I think that I think both are great actually. I think sometimes people ask me, should you do a PhD maybe at Stanford, or should you get a job at one of these companies? And or should you? Some people ask me, should you do a PhD or should you apply for a job in a company? And to me, that question is a bit like saying, should you move to Silicon Valley or should you move to New York? Actually, no, move to Silicon Valley. It's like saying, should you move to Seattle or should you move to New York? And I would say it depends on where's your family, what job offer did you get in Seattle, and what job offer did you get in New York. So if you're trying to decide, should you go to one of the top universities or go to one of the top machine learning groups, I would really treat them on an equal basis and apply to PhD programs and apply to jobs in industry, and then select the one that gives you the best learning opportunity. Right? So again, the teams I mentioned, if you get a job offer from them, take it. If you get to Stanford PhD program, take that. But if you get into other programs, other job offers, then look at them on an equal basis and evaluate which one gives you the best learning opportunity. And it's not obvious. Some PhD programs are better than some jobs and companies, and some jobs and companies are better than some PhD programs.
Great. Now, this is my personal question. And before you start Coursera, you said your passion is education. And then you work for the industry. Now you are coming back to deeplearning.ai, I guess. So does that mean you come back to your passion, and what's your future plan for deeplearning.ai?
Yeah, so, audio? All right. So deeplearning.ai, and we actually have a booth outside. If you want to learn more about deeplearning.ai or robot or dry.ai, stop by the deeplearning.ai booth outside. But I'm very excited about helping build an AI-powered society. And so I'm working on some new businesses. I think there are some exciting things in healthcare, in autonomous driving, in other things I have not yet announced that I'm working on. But machine learning offers so many opportunities. There's no way for me and the teams I work with, or even any single company, to do all the work that needs to be done to create so much value that machine learning will create. So one of the things I'm very excited about at deeplearning.ai is to give millions of people, to give all of you these tools so that you can go and do a lot of the wonderful projects that I know I will never think of myself and that I will never do. This will sound naive, but the thing that actually gets me out of bed in the morning is the idea that in the next few years, we could build an AI-powered society. I would love for someone in a village, in a developing economy, to figure out how to use machine learning to improve their water supply. And I will never think of how to do that myself. I hope every child will have a personalized tutor. I think healthcare needs to deliver higher value services at lower costs. And there are just so many things that society can do that will benefit from machine learning. So I think that I hope to help many of you, frankly, do the important work to build that type of society.
One last question. What's your vision about the future of deep learning?
Even if we stop publishing papers in deep learning, we have enough technology to transform every industry. So I think there's important work for all of us, frankly, for all of you as well, to do using deep learning to transform human life. Beyond that, I find basic research still super exciting. I think that I would love for there to be a breakthrough in unsupervised learning. We're all excited about that. We just have no idea how to do it. And I think that if there are these additional ways of technological breakthrough, then it will unleash additional waves of products and services and transformations of industry. And maybe, I think as a society, we can't all do one thing. So I think it's great that some of us are working on AI for healthcare, AI for self-driving cars, AI for mental health. But then I think is also we need some of us to be working on basic research to advance the algorithms to unleash the future waves of progress as well.
Thank you very much.
Okay,
Let's
thank you.
thank Andrew.
Thank you all.